Okay, hello folks, and I know that you are very tired, but at the end of the day I think we are going to start learning some pretty cool stuff. My name is Redi, and I actually am the co-founder of the company called Codemodon. In the same time I am a PhD student at Yazılım Technical University. The projects we are actually working on, as you maybe have seen in the hall outside, there is a cool game there called Android Football, and many of you may have played that game. It is pretty much the thing we do every day. So we develop games that are used for different brands, which makes them to be marketing-based games. So, who are you? As I was actually asking before, I asked that how many developers are here, and I saw that most of you are developers. And is there any designer here? No? Oh, okay. And as you are developers, of course, you have a programming experience. And do you know anything about Unity? Okay. You just have maybe listened about it or just early work. How many of you have been working with Unity? Oh, okay, good. Firstly, I want to make something clear. This presentation does not include how to program, because I saw that you are developers. So we will not be talking about C# or maybe JavaScript or BootScript, which is another kind of script. And shaders, it is an advanced programming language used for GPUs. And of course, because of the time limitation, we don't have too much time to explain everything regarding the Unity 3D. So, pretty much, what is Unity 3D? It is a gaming engine, firstly, which offers you a very cool platform, which has the engine, the motor, and it has also the studio where you can develop the game and work over that. For the code editing, it uses the MonoDevelop, the open source project, actually working on Mac, Linux, and Windows. It is a project started in 2005 with a really simple studio, which now in 2013 it became a very big and important topic for many developers in the world, actually a bunch of millions, I think. And it has been coming with two versions, with the Unity Free and the Unity Pro. The difference between Free and Pro, in fact, firstly, is the different license types. So if you are a company, you've got to have to use the Pro. And with this year, they started offering at Unity Free the free mobile packages. So until the last year, you were using the Unity Pro, I mean, paying about of $1,500 per license. And it was that if you have to be working with mobile devices, you have to purchase the Unity Pro, but this year it was free, which made, I think, a bump in this development category. As you see, the screen is full with many different platforms, which makes it that the Unity is a tool which offers you to write the same code and export it in all the different platforms. I think you are familiar with these logos. And so I'm not going to start counting them one by one. Basically, we are going to stop at Android as an example, but when you use Unity, it doesn't mean that you are developing solely for Android or just maybe Windows or iOS. You are developing the same thing for every kind of this category, but here I will just stay on many important topics which make it possible to develop an application which performs well on mobile devices. So there is, in fact, nothing specific about Android, but there is something specific for the mobile devices. Okay, the Unity comes with a pretty editor, which makes it possible for you to, up to a place, to design, and sometimes just write some code. After that, make it possible for you to test it inside the environment before publishing it. And these are the 5 main units of the developer screen, which we are going to see in this example here. This is a kind of example scene when I tried to make it much more simple and divide it into 5 parts. Firstly, in the screen upper there, you've got the part where you manage all the objects in the game. If many of you may have used 3D Max or Maya for designing, you're going to find a similar environment there where you can move your objects, usually the 3D objects, inside a 3D world with X, Y, and Z coordinates. In the screen below, you always can see a preview of your current game. So it makes a simple rendering of the screen that's going to be shown after the compilation, and makes it ready for you in another screen just to see a preview. So for example, you set an object in the upper part, but you put some lights and some shadows, and the final operation is going to be seen in this screen. In the screen number 2, you have the list of all the objects which stay inside the screen. So for example, you've got a ball, you've got also maybe a soccer field, and you want to just throw the ball into the soccer field. You just drag and drop your 3D model, which may be coming ready from 3D Max or Maya or any other 3D environment. Below you've got a simple file manager where you can drag and drop the objects that I mentioned before. And in the right part, you can set up, I think it's a bit bluer because the screen is so large, but I'm just going to make it shortly. You can set scripts properties as height, width, position of coordinate, zoom, sizing, and rotation in the upper screen shown there. So this studio, in fact, offers you a pretty good place for developing and also moving your objects, designing, and make it possible for you to produce a game all in one with this studio. Okay, we talked about a general overview of the studio. What you can do, you can just put the models, use them, add codes for those models. But I'm just trying here to summarize some very important actually keywords for this studio. So when you start developing a game, usually a 3D game, you should be aware there is such thing called as camera. So always what you show to the user is what the camera object catches. So the camera has a point of view, it has a distance, it has a position in the screen. So anything that the camera, which you really drag and drop in the screen, sees is what your user sees. After that, as we all perceive, everything is constructed by light. So you need to put light inside the environment in order, again, for your user to see that application. So light is really basic and should be used. Another thing is the 3D game object. By the way, game object in Unity means everything which is part of your studio and is part of your game. So light is a game object, a 3D model is a game object, maybe a plane or a picture is a game object. After that, your game may have voice, may have sounds, may have a background sound, and this is what's so-called audio source. Also, there are some basic shapes. Many of you that may have used DirectX or OpenGL or any other platforms should be familiar with putting shapes, 3D shapes, which may be spheres, cubes, many different polygons. The MonoDevelop is the place where you write your code. At this hour, I think that it's not a good idea to start writing code after this tiring day, but I'm just going to give a general overview about the code. This studio here is connected with the previous screen we saw. So in the Unity 3D editor, we use our models and put them in the screen, but in the MonoDevelop, we write C#, JavaScript, or Boolscript. What we prefer and what we actually advise to do is using C#. If you search in internet about Unity samples, you may see JavaScript, Boolscript, and C#, but what actually is preferred is using C# because it is an object-oriented language and not a language like JavaScript, which is not strongly typed. In a game, beside the objects and beside the lighting and designs, you need to use physics, I mean real physics. So if you draw a sphere and you want to throw it in a soccer field, you need to use gravity, friction, maybe some wind is around there, so the object needs to be moving with the wind. And in the same time, maybe an object is just colliding to another object. So these are the basic part of terminologies used for physics. So we had a gaming studio, which offers you a designing place where you can put your objects there. Also, it comes together with the editor, which is the MonoDevelop, which makes it possible for you to use code by moving the objects, by changing the objects, and sometimes also by loading the objects. And as we said, the game engine, which is the most important part of Unity, is the physics. When we write code, maybe we create a project, maybe we create a game, and some people are used to, usually within a company. If I do something, I want also my friend to do that. Or if my friend does something, I don't want to write the code from the start. And Unity came up with a pretty cool choice, and they made the asset store. So as you purchase maybe applications from App Store or Google Play, the same thing is right here. They are not complete applications. They are source codes plus modules. So for example, you want a tennis racket, and you don't know how to do that. You just search in this store and find a tennis racket, maybe animated, maybe together with physics, maybe with the tennis player. And after you just get the results, you may get some free ones, you may get also some paid ones. So Unity Asset Store is an environment you should reach when you need something and you don't want to write it from the start because some other people did it for you. Is there anyone here which has been using Flash, Adobe Flash? Okay, so I think pretty familiar with the keyframes and the timeline. Beside the attributes that we mentioned, we have also the animation part. The animation comes with a timeline editor, so each object's properties can be animated within a given timeline. So for example, you've got an object placed in a simple part of the screen, and you want to move that object within 3 seconds, or maybe you've got a person there with hands and legs and body, and you want to animate its parts. You can use keyframing as you perfectly use at Adobe Flash, and you can create animations within the studio. So animation is also another much more important part of the Unity editor. Well, all this general information, I think, should be concluded through the mobile environment. So, based on my personal experience as a developer, and also based on the experience of my teachers and people who I learned from, I'm going to give you some advices and some pretty cool stuff that you need to use while developing, especially for mobile. So, when you develop something and you see it runs pretty cool in a PC, you just put it in the phone, it crashes. I've been used to have that situation very much. Setting up the Android environment is as much simple as just downloading the SDK. So what you do is download the SDK. This screenshot has been taken from a Windows PC. You can use it on Mac and also in Linux. You just download the SDK. There is an Android SDK location inside the preferences. After you choose that, automatically Unity is able to compile APK files and produce them for your phone. By connecting with the USB debugging of your phone, it can automatically deploy applications in your phone within a single minute, maybe. So setting up the environment is really easy. So you don't need to get Googling too much for that. Okay, the mobile phones usually at Android, because at Apple there are sometimes some fixed resolutions, at Android there are many devices. There are many kind of tablets, many kind of phones, many kind of maybe small PCs that work with Android. So the first thing you need to think about is the aspect ratio. When you are planning to develop a game or an application, you need to know, who am I developing this for? And which device am I developing this for? So for example, you've got a small Android phone with maybe a 720p screen, and you've got also another one with a 1080p screen, and you want the application to look same in the same phones because you don't want to make another application just for another size. It's not logical, especially in Unity, which is an environment used in multi-platforms. So the first thing you need to think about is the aspect ratio. You should never be using fixed size. You always use parameters and make it as a scale, but not, for example, make it as 3 pixels. You will always be using units, which are automatically scaled in every phone. Also, another important part, which is not possible for PC, is the screen orientation. So let's assume that you develop the application in 720p and portrait mode, but you want it to work also in landscape mode. You just can set it up inside the editor. You can create custom resolutions and custom aspect ratios, and you can test your application within seconds in different aspect ratios. Another cool feature I think that is very important, especially for the paid application, is the anti-piracy check. Some people hack the devices, so when they purchase a paid application, they can extract the APK file and change it into a level that makes it possible for another users using it in phone for free. So what Unity does is that before producing the application, they make a check. This check consists of, is the application signed with the store ID? If the application has been broken or changed, it automatically can trigger you an event. So you can check within the application if your application has been, sometimes in this case, hacked. And shadowing, lightning, putting objects, moving them apart is easy and works very well in PCs. You maybe use an NVIDIA with 2 GB of RAM and it works very well, but in mobile phones it's not possible. So you need to develop an asset set which can be downloaded or just be taken from someone from the mobile assets from the Unity store. It is a free set of some packages using some shaders and some utilities which make it possible for you to use them in mobile applications without losing performance. So I think for every mobile project this is a must. When we develop the application, and as I mentioned, you write it down, it works very well in PC, you call your friend, you say, just look at the application, it's working okay, but when you put it in the mobile phone, it just crashes, or maybe has a lag, or maybe it slows down. So what are our performance enemies? The first one, high polygon models. What you know is that some people, actually, developers don't care about that, but designers care about that. Designers, 3D designers especially, know every detail of their 3D model. So sometimes when you get a 3D model, you can check and see that it is not working very well on mobile devices. What it means is that this 3D model has too many parts. It cannot be loaded from the graphics card of this mobile phone. So what we need to do before going to a mobile device is telling our designers, please do not give us high poly models. High poly and low poly are just the shortenings of the high polygon and low polygon models. This is a key feature because you're going to see that if you get, for example, a stadium into the mobile phone, you're going to be able to open that. You need to reduce the number of polygons of that model in order to open that in the mobile phone. Another problem that developers face with the performance is shadowing. Shadowing is really, really expensive, especially in mobile phones, because every pixel in the screen and every object should be calculated and thrown again into the screen in order to make it possible for you to have smooth and blurred shadows. So in Unity, there is an operation called baking. Yeah, right, baking, as you bake the bread. Actually, the light, when it comes into the objects and creates a shadow, usually for static objects, for example, you've got this piano here, you've got also a shadow maybe right here, and this piano is going to stay here all the time. Just I am a 3D model moving around this piano. So what you do is choose this piano as being a static object and baking all the lights in the scene. So what you do is pre-render the shadows and make it possible to be there in the compilation time. So the mobile phone doesn't need to calculate every vertex of the 3D model to be displayed in the screen. And after you bake this scene, after you make all these lights being inside the pattern, it's going to be much more easier and it's going to run much more faster in your mobile device. Besides these two important things that personally I've been facing very much during the last period, it's not advised to use models and load them in the runtime. So for example, before starting the game, you just may put some loading part inside the game, but after the game opens, it is not logical, and at the same time, it's not advised to call the models and load them from files within the scene, because mobile devices cannot deal with that. In PCs, sometimes it's working correctly, but on mobile devices, you need to put all the models in the scene, load them, and maybe you can hide them. It's much more better to load them and hide them than loading them while you are working inside the scene. And I said that I will not be talking about shaders, but I think that it's an important part here. For example, you are trying to do a mirror effect. What you do is check all the pixel, reverse all the pixel, and make a mirror effect for maybe a webcam. But when you write code on C# and this code will be compiled on your processor, every screen operation is going to be handled by your CPU. never by your GPU. GPU uses shaders. So in order to make GPU working with your code, you need to write shaders. It's a kind of language similar maybe to C++ or C, but of course not as easy as C#. That's why shading is an advanced topic, which is another level of development. So basically, these were the topics I prepared today. As I said, I won't be talking about coding because I assume you are all developers, so a basic check for Unity on Google is going to show you everything. But I just wanted to make you a bit familiar with this environment, and maybe for those who don't know Unity and its possibilities, to at least this evening get at home and check it, how it works and what operations can be handled doing Unity. So I thank you very much for listening me to this very late hour. And if you have any questions, you can maybe also write me an email or just ask right now, or as you wish. Thank you very much then. I wish you a very good evening and enjoy your time.